In this video, we'll look at one application of solving quadratic equations, and that application is projectile motion. Because of the Earth's gravity, a projectile launched into the air will follow a parabolic path. So what that means is that our projectile will start out low, it will go upward to some high point, and then start falling back down again. For example, if a ball is thrown upward at 64 feet per second from a height of 12 feet, the height of the ball can be modeled by this quadratic equation. H equals 12 plus 64t minus 16t squared feet, where t is the number of seconds after the ball is thrown. How long after the ball is thrown is the height 40 feet. Round your answers to the nearest hundredth. All right, so I want a height of 40 feet. So I'm going to go ahead and put 40 equals 12 plus 64t minus 16t squared. All right, now the ways to solve this are we could try to factor it, or we could use the quadratic formula. Either way, we have to set our quadratic to be equal to 0. So what I'm going to do is I'm going to move all the terms to the left-hand side of the equation. So I will add a 16t squared to both sides. And I'm going to write it over here on the left. I will subtract a 64t from both sides. And I will subtract 12 from both sides. So lining everything up, I'll have my equal sign in the same spot. But on the left side of the equation, I'm going to have 16t squared minus 64t. And then 40 minus 12 is going to give me plus 28. And now everything on the right side of the equation canceled. 12 minus 12, 64t minus 64t, and negative 16t squared plus 16t squared. So I end up with 0. So now, whether I'm trying to factor or use quadratic formula, I can identify my a, b, and c. I'm going to go ahead and use quadratic formula just because we have that large number in front of the t squared term. So I'll say a is 16, b is negative 64, and c is positive 28. Now let me remind you of the quadratic formula. We have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so I've identified my a, b, and c. You cannot identify them until your quadratic equals 0. So I had to do that part first. And now I'm going to go ahead and plug it in. So I am going to have x equals negative and then negative 64, so a double negative there, plus or minus the square root. I'm going to put the negative 64 in parentheses so that I make sure I square the negative 2, which would make negative 64 times negative 64, which would give me a positive, minus 4 times 16 times 28. So 4 times A times C. And that entire expression is over 2 times 16, 2A. So I like to solve these in steps here. The double negative here, negative negative 64 gives me a positive 64. I'll have plus or minus. And now I want to use my calculator to figure out the radicand, the digit, the number that is underneath the square root. Sorry about my screen jumping around. I'm not sure what happened there. Okay, so I have my calculator. Let me clear these out. All right, so now I've got it in the right spot. I'm ready to put in the radicand. So I'm going to put parentheses, negative 64, close the parentheses and square, minus 4 times 16 times 28. So 2,304. But remember, that's underneath a square root. So square root of 2,304 all divided by 32, because 2 times 16 is 32. So I've got two answers here. I'm going to have one with the plus and one with the minus. So I'm going to have x equals 64 minus square root of 2,304 all divided by 32. And I'm going to have x equals 64 plus the square root of 2,304 all over 32. Now, when you put this in the calculator, the way that you can show that you have a sum or difference in the numerator is by putting parentheses around the numerator. So I could put parentheses in front of the 64 and after the square root, and that would tell my calculator that that whole thing is in the numerator. Okay, so I'm going to put parentheses and then 64 minus the square root of 2,304. Get out of the square root and close the parentheses and then divide by 32. So 1/2 is my first answer, or 0.5. And then I'll do the one with a plus. So I'll do parentheses 64 plus the square root of 2,304. Use your arrow to get out of the square root, close the parentheses, and then divide by 32. So I get 0.5 and 3.5. And x equals 3.5, 0.5 and 3.5. Now, one thing here, notice that my original variable was actually a t. And I actually forgot that when I was solving. So I could actually come back here and just change this to a t. The way that we solve the equation ends up the same. You just want to make sure you're using the correct variable in the end when you give your final answer. So all the x's should be t's. And so my answers are going to be t equals 0.5 and t equals 3.5. And our units are in seconds. You can go back to your original equation and look at what your variable is representing. They say that t is the number of seconds after the ball is thrown. And so if you were asked for the units on your answer, then you would just come back down to the bottom and you would write in seconds. Now, checking the answer, we've gone over this in previous videos, but to check your answer, what you would do is you would take those values and plug them in to your original equation. So my original equation is 40 equals 12 plus 64t minus 16t squared. So if I wanted to check, I would do 12. I'm going to do the right side of this equation. So 12 plus 64 times 0.5 minus 16 times 0.5 squared equals 40. So the 0.5 seconds checks out. I'll do the same thing for the 3.5. 12 plus 64 times 3.5 minus 16 times 3.5 quantity squared. And I've got 40 again. So both of those t values make my original equation true, and that's how I check my answer.